Hey everyone, welcome back to another video. So in this video, I wanted to talk about something that came up this week for me at work, and that's how do you structure your infrastructure as code before you actually write it so that you can future-proof it and make it easier for yourself in the future to maintain that code. So let's go. So let me tell you the story about what happened this week that prompted this video. A internal customer of ours is requesting for us to deploy certain infrastructure in our cloud provider, which is Azure. And they've come up with this solution with Azure Functions, App Service Plan, App Service Environment, and all that stuff. What came up this week was that the final goal of this project was much bigger than what we originally anticipated. And what was requested, if we had coded it the way they wanted it to be coded in the original request, we would have a lot of problems in the future supporting that code. Let me walk you through some of the steps we've taken to write this code properly. In order to be ready to write your code, you have to follow a few steps. And it all starts with your customer, the person who's requesting the work from you. You have to figure out what is the problem that they are trying to solve. Understanding the problem that they are trying to solve will really help you understand what you have to do to get a successful project done, right? So if they are trying to get data to a customer, then the project is done when you have infrastructure that is capable of getting your data to the customer. The next step is to understand how they envision the solution to look like in a few years. What is their what's called blue sky solution? So if they can have any solution regardless of technology, regardless of product, what would an ideal solution look like 3 years in the future? Now, it is important to ask for what they want in the future because one, you don't want to set the expectation that you can do it. And two, it gives you enough idea about how your customer sees the product that you are building for them growing to allow you to build into your code room for these potential future improvements. They may not happen, but if you're ready for them, then it will make it much easier in the future. If you build things, for example, with Terraform, and you make a list, right, of resources. Now, if you move any items within this list, this will cause Terraform to delete all your infrastructure, or at least whatever is in that list, and recreate it all because Terraform really wants a list to be ordered. And when the resource that is associated with an index in the list does not match the resource that it is supposed to create, it will delete and recreate it. So the solution for this is to remove the resource from Terraform and add it back to the proper index. And that makes a lot of work. So if you understand, like, you may remove resources, you may add resources, you may change the order of resources, it really helps you design the code in a way that allows the customer to do what they want to do in the future without having to do major rework to the code, which is something that we could have set ourselves for if we had gone with what the customer asked for at the beginning. The third step is to talk to your customer about what is a deliverable product now, because you want to make sure that you understand how the product will grow, but you also want to be sure to be able to deliver a solution that is working right now. It gives you the starting point and the end point, and you can work from there. It allows you also to understand what can you do and what can't you do when you write your code, because some things may take too much time to implement. The next step is to look at the architecture. You have to architect your solution. So you have to do drawings like this one, where you come up with your solution, your resources, how they talk to each other. And you also have to do copy and paste. You have to multiply it so that you can actually visualize what happens when your infrastructure scales, and you can look at the plan and write your code, and you have that visual picture about what you are trying to do. Now that you have your plan in place, you should work with pseudocode. So pseudocode, if you don't know what that is, it's code for humans to be able to describe in a code-like fashion what your program would do without actually doing the code. So for example, here's some pseudocode for you. So create an app service environment, then create multiple app service plans under that environment. And then for each environment, create a set of functions, Azure functions, to be run on that plan. So that's your pseudocode. That's a very crude pseudocode, but you get the idea. And this gives you a framework on what to work on. It allows you to figure out all the pieces you need. You have a rough structure of what you're going to be working on. And that's very helpful. And those pseudocode lines are your bones, the skeleton for your future application. Those will transform into comments in the future. Now that you have your pseudocode, you have to define your inputs. What can change? What is dynamic in your infrastructure that you would like to change right now or in the future, and come up with these inputs for your code. And then figure out how do you take that input and communicate it to your pseudocode. So for example, do you want a list, so an array or whatever you call it, a list of items as your input? Is it something that you're going to change in the future? Will you always add at the end, or will you want to change the order? These decisions really influence how you're going to code. And at the same time, you have to think about what happens when you add or delete or multiply certain of these inputs, and how will your code behave? How do you think your code will behave when you run it in your head when you do these changes? And are those behaviors acceptable? For example, like I mentioned previously, if you have a list, the order matters. So if you run through the list in reverse, a program like Terraform will delete all your resources and recreate them all because they're all different. Whereas if you use something like a map, then it won't do that because it's going by keys. So if you delete a key, then it will delete whatever that key is, but it won't delete the other resources. You have to think about how your code will behave with your input and adjust your input accordingly. All right, so now that you have your code and you have your pseudocode done, you're now ready to start writing code. And I recommend that you don't write the whole code at once, right? Write a small piece and try to run through these use cases of varying your input as you test your small chunks. Like, will these small chunks behave the way you expected when you add, remove, multiply inputs? Will this all work? So a few key points that you have to keep in mind when writing your code are scalability and flexibility. So scalability is not only how does the infrastructure itself scales, but how does your code scale with the infrastructure? The bigger your infrastructure, the bigger your code, or is it just a matter of changing the inputs? Ideally, your infrastructure scales faster than your code does, meaning that scaling your infrastructure is just a matter of making a small change in your code. Think about it as hard coding resources, right? You want resources X, Y, and Z, and now you have them, and next time you want to change your infrastructure to scale that, to multiply it, to get different copies of it, you now have to take all this code, take X, Y, and Z, paste it somewhere else, change the name of X, Y, and Z or whatever, and that's your code. It just keeps building through copy paste, right? And it's as big as your infrastructure. On the other hand, you can set it so that you have some sort of a loop or counter or whatever you want that says, okay, if I have X amount of this and I'm going to say, here are the names that I want for X, Y, and Z. And now if I want to change X, Y, Z, or I want to scale it to add more, I can just add more names to that list. Hard-coded change usually is a bad thing. It can get extremely extremely complicated. If you make it so that all you have to do is change your input, you make your code more legible, and hopefully your code doesn't scale, but your infrastructure does. The next thing to keep in mind is customization. So you want to be able to be flexible in what you do, but you don't want to be overly flexible, right? There's like the overly flexible where you input every single thing that you would have to put in your resource. Your input is one-to-one with what needs to be inputted. On the other hand is the hard-coded version where everything is hard-coded and you have no flexibility. So you have to figure out what is the right middle ground between those two things. And in order to do that, you have to look at what will change. What will change in the future? And that's where you have to ask those questions of your customers before you start coding, because that will impact your input. So what will change? What can you change? Are there things that you cannot change? For example, security features, right? You will have HTTPS, you will have encryption, you will have permissions, all these things that you know can change, right? Hard code those. All these things that you know need to change, that can change, make sure you make it flexible enough to handle these changes. The more flexibility you give the user, the person who's inputting the input, the more code you're going to have to make to accommodate these changes. So it's really like it's a balance between how flexible do you want it to be for the end user and how quickly can you turn around that flexibility for your end user. So writing code is really about finding that middle ground. Your ideal state is somewhere in the middle where you don't give full flexibility, but at the same time you have enough scalability. So it's up to you when you write your code. It's a challenge, and it's one that you're going to have to solve every time you write code. But I have to say that the more code you write, the more of these problems you solve, the better instincts you have about how you want to structure things, how you want to organize your code, and how you translate the user's input into usable code. So don't be discouraged. Now that you've written your code, you've tested it all, it is time to deploy it. And that's the exciting part because it basically means you are done for now. You're going to hand it out to the customer to do testing, and then you'll repeat the development and the development and deployment cycle. But overall, you're done. So congratulations, that's what you did. And now, if you have questions about infrastructure as code, I highly recommend you visit this video, and I will see you in the next video. Bye!